You could get to Mars in just 30 days. No, this isn't sci-fi. A new, breakthrough plasma engine could actually make it happen. Pretty soon, we might be swapping our beach chairs in the Bahamas for a trip to the Red Planet. So, when can we buy our tickets? Well, probably not until 2030. And even then, those first rides will probably be a luxury reserved for astronauts, not tourists. They're already thrilled though, because this engine could change everything about space travel, cutting flight times way down and making missions a lot easier to handle. Right now, traveling to Mars is just a dream. Nobody's ever set foot there, and there's one big reason why. A round trip would mean spending years stuck in space. And that's anything but safe. We did send people to the moon though, but that's a whole different story. Getting to our natural satellite only takes a few days. The fastest trip was Apollo 8, when the crew made it from Earth's orbit to the moon's orbit in just under 3 days. If the team wants to save fuel, they might choose a different route to get there. And those paths can take way longer, sometimes weeks, even months before they finally reach the moon. So how long it takes to get there is more of a strategic choice. Now, what about Mars? Well, the Red Planet is a lot farther away. On average, it's about 140 million miles from Earth. According to NASA, even if you could hop on a spaceship right now and head straight there, the trip would take anywhere from 7 to 10 months. Take NASA's Mars Reconnaissance Orbiter, for example. This spacecraft launched from Cape Canaveral in August 2005 and didn't reach Mars's orbit until March of the next year. How long the trip takes can change though. That's because the distance between Earth and Mars is always changing as they orbit the Sun. So even if we can get there in a few months, a round trip could end up taking nearly 3 years. And nobody wants that. Not just because it'd be boring to live up there without Netflix, but because it's seriously risky. Spending that much time in space can do real damage to the human body. You see, a mission to Mars would put astronauts through 3 different gravity fields. First, during the trip to Mars, they'd be weightless. Then, once they arrive, they'd have to live and work in a gravity that's only about 1/3 as strong as Earth's. And finally, when they come back, they'd have to readjust to Earth's gravity. Switching between all those gravity fields is no joke. Astronauts can lose their balance and sense of direction, which can cause nausea and confusion. Dealing with that while landing a spacecraft on Mars is definitely not fun or easy. That's just one set of problems. There are plenty of other challenges with a trip this long, like a communication delay of up to 20 minutes one way, the risk of equipment breaking down or medical emergencies, and the constant need to carefully ration food and supplies. Thankfully, the new engine I mentioned earlier might just save the day and could make the trip way shorter. Or at least, that's what scientists are saying. They've built a prototype of plasma electric rocket engine that could get us to Mars in just 30 to 60 days. And if your first reaction was, a plasma what? Don't worry, I'll explain. So, here's a normal rocket, the kind you see blasting off from Cape Canaveral. It works by pumping liquid hydrogen fuel and liquid oxygen oxidizer into its engine. When the fuel burns, it releases a ton of energy, creating thrust. In simple terms, that burning makes super hot gas that blasts out the back, pushing the rocket forward, and off it goes. Now, here's the plasma rocket. It takes off pretty much the same way using the same chemical mix to launch. But once it reaches orbit, it switches over to an electric propulsion system, and it works completely differently. Instead of burning liquid hydrogen and oxygen, it uses 2 electrodes. When charged particles move between those electrodes and a high voltage is applied, the current creates a magnetic field that pushes the particles out of the engine. That superheated plasma shoots out in one direction, and the spacecraft moves in the other. That's how it creates thrust. We're talking about at least 6 newtons of thrust. To give you an idea, 1 newton is about the same force it takes to hold up a small apple against gravity. Sure, that sounds tiny compared to the explosive power of a normal rocket, but here's the thing. A plasma engine can run non-stop for months. gradually accelerating spacecraft to extremely high speeds. Cool, but how fast are we talking? Well, regular rockets that burn fuel can reach a maximum exhaust velocity of about 2.7 miles per second. Meanwhile, this new plasma rocket can hit around 62 miles per second. At those speeds, a rocket trip to Mars could only take a month. That's a huge difference. That's why people think this new engine could completely change space travel. By letting spacecraft go way farther while using a lot less fuel, this tech might finally be what we need to leave our footprints on the Martian surface. And who knows, maybe even go beyond that. But it's not exactly ready yet. It could take years. Right now, it's more of a prototype, still in a very early stage of development. It's being tested inside a special facility, a 46-foot-long vacuum chamber about 13 feet wide that simulates the conditions of space. The whole idea is to see how the engine performs in realistic conditions before actually sending it into orbit. One of the things they might want to test is how it reacts to gamma-ray radiation. Because out in space, radiation isn't just sunlight. It's streams of tiny subatomic particles coming from the Sun, the Milky Way, and even beyond. They may be small, but they're still a major challenge for long missions. Because here on Earth, radiation from the Sun and space isn't a big deal. Our atmosphere and magnetic field absorb or deflect most of it. But astronauts and their spacecraft don't have that kind of natural protection out there. The problem is that these high-speed particles can pass right through the human body. They can tear through DNA molecules, breaking them apart and causing serious health problems. Even just an hour without proper shielding could be life-threatening for us. Well, for the astronauts, I mean. But it's not just humans. Spaceships take a hit too. These particles can penetrate the spacecraft's materials and damage sensitive electronics, causing glitches, malfunctions, and even complete failure. That's the last thing you want on a long space trip, right? It's not like there's a pit stop with a mechanic on the way to Mars. And with a round trip taking over a year, that's a huge problem. The longer astronauts and their ship are exposed, the higher the risk. That's why finding ways of getting to Mars faster is so important. But the creators of this plasma engine are not the only ones racing to get to Mars with faster rockets, though. NASA recently teamed up with the Defense Advanced Research Projects Agency to test a nuclear thermal rocket engine in space, a technology that could also cut down travel time for future human missions to the Red Planet. Meanwhile, SpaceX has even bigger ambitions with their colonization program, better known as Occupy Mars. Their plan is to send people to actually live on the Red Planet, hoping it'll help humanity survive in the long run. They're planning to launch the first starships there in 2026, but they'll probably still be uncrewed. The scientists are confident that those ships make it to Mars in just 6 months. So, we've got a plasma engine, a nuclear thermal rocket, and a whole Occupy Mars mission all racing to get people to Mars very soon. But who is really going to pull it off first and get there the fastest? I guess only time will tell. But hey, you can drop your guess in the comments. Welcome aboard the most innovative, powerful, and safe spacecraft, Chrysalis, which will take you to exoplanet Proxima Centauri b of the Alpha Centauri star system. Thousands of brilliant minds have been working for decades to provide you with a comfortable journey through the depths of boundless space. You won't live to reach your destination, as the entire way takes more than 400 years. But rest assured, your descendants will reach Proxima Centauri b completely healthy. Now let me give you a tour of the ship and show you how it works. To ensure that living conditions on Chrysalis are as close as possible to those on Earth, scientists equipped the ship with artificial gravity support. Thanks to the rotating hulls, you'll be able to walk here as if you're on your home planet. And the ship's length? A whopping 36 miles. Will definitely ensure you take long walks. You can sit on a bench in the park where botanists have planted flowers and trees grown on board. You can visit a library or have lunch at a cafe. You can meet your friends in the evening, or you can spend time at home watching documentaries about wildlife. Maintaining an earthly standard of living on the ship is possible thanks to the operation of thermonuclear reactors and the unique design of chrysalis. The whole ship is built like a nesting doll. Several layers of the ship cover one another and spin around the central core. Each layer is equipped with a fusion reactor and public spaces, farms, warehouses, natural parks, technical departments, and many other facilities. The center of the ship has communication equipment and shuttles that will take you to Proxima Centauri b after chrysalis approaches the upper layers of the planet's atmosphere. Factories for the production of food, plants, mushrooms, insects, microbes, and livestock are located on the level closest to the core. Earth's biodiversity is traveling with you to the neighboring star system. In order to maintain this biodiversity in natural conditions, engineers have equipped the ship with tropical and boreal forests. Scientists recommend regular visits to these natural areas to reduce anxiety and homesickness. The second level is designed to support passengers' social life. There are parks, schools, libraries, and hospitals here. Community and spending time together should protect you from existential horror and distract you from realizing how far away you are from your home planet. The next level of chrysalis has an air and heat circulation center. If the core is the heart of the ship, then this area is its lungs. Then there's a layer designed for waste recycling, construction, and numerous factories. There will always be something to do on the ship, and you will never be out of work. This means you will never face a financial crisis. The last and furthest level from the core works as a giant warehouse for storing various resources, materials, equipment, and machines. In order not to burden people with additional work at this layer, engineers placed robots with artificial intelligence here. The ship's complex and multi-layered systems work to provide the passengers with the feeling that they're on Earth. But if you want to remind yourself where you really are, you can go to the front part of chrysalis, where engineers installed a so-called space dome with a gravity zone. Here you will have a great time with zero gravity, enjoying an incredible panoramic view of space. In order to maintain a stable demographic and not provoke overpopulation of the ship, it's necessary to have at least 1,500 people on board. That's 900 people fewer than the stated capacity. Engineers and pilots responsible for managing the spacecraft will be cooperating with artificial intelligence. But of course, no comfort makes sense without security. The chrysalis body has a cylindrical shape with a narrow front, which reduces the risk of impacts from small meteorites and space debris. Mobility, speed, and long flight time are provided by an engine working on a nuclear fusion isotope of helium and deuterium. It gives the ship a simultaneous boost of thrust and electrical power. Now, all your attention should be focused on the preservation of the human species. Over the course of 400 years, while the ship travels to its destination, several generations will change. Your kids and future descendants won't get the experience of living on Earth. Skilled teachers, engineers, and other professionals, along with artificial intelligence, will teach the next generation science, culture, and all the necessary knowledge that will help build our civilization in a new home. The success of the mission also depends on the psychological state of the passengers. For this reason, not everyone will be able to access the chrysalis board. To adapt the human brain to the conditions of terrestrial isolation, the first generations will need to spend approximately 70 to 80 years in a remote area of Antarctica. Obviously, after such a long period, many won't be alive anymore, but they will make their descendants ready for a space mission. The first generation will never see space and will spend their entire lives in the cold Antarctica. What kind of person can be prepared for this? Their renunciation of the world and sacrifice for the sake of other people will set an example of the highest manifestation of love. This fact adds more responsibility to your mission. You've just watched the presentation of the Chrysalis project, which won first place at the Project Hyperion Design Competition. A group of specialists has prepared a well-thought-out plan to create a spacecraft capable of taking us to the nearest planet suitable for habitation. According to estimates, this ship can be built in 20 to 25 years. But first, people need to invent fusion reactors. This project is a practical instruction on how to start the expansion of space, or how it can work like Plan B in case a global catastrophe happens on our planet. But what is this planet that has captured the minds of scientists and astronomers? Could it potentially become our new home? Proxima Centauri b is located 4.24 light-years away. It's not easy for the human mind to imagine and realize this distance, but relative to the entire outer space, it's very close to Earth. 1 light-year is the distance that you travel during 1 year moving at the speed of light, which is approximately 983 billion feet per second. The distance Chrysalis would have to cover is about 25 trillion miles, and the time needed for this journey is about 400 years. The ship would accelerate during the first year of this long voyage, and it'd slow down for the last year of the trip. It'd be a long, risky, and very exciting journey, but the result would be worth it. Proxima Centauri b was discovered in 2016. Its mass is 1.1 times that of Earth, and it orbits its star every 11 days. The distance between the planet and its star is ideal for getting enough light and maintaining temperatures above the freezing point of water. But because of this proximity, there is a possibility that Proxima Centauri b is under a strong influence of gravity and orbits the star with one side, like the Moon orbits Earth. Anyway, the planet immediately attracted everyone's attention because it turned out to be very similar to Earth in many ways. Scientists used special computer models to study Proxima Centauri b. The same models are used to study the climate of our planet. They found out there might be huge areas of liquid water in that distant world, and probably living organisms. But if the planet is always facing the sun with one side, there's probably a huge temperature imbalance. Fortunately, this problem can be solved. According to new calculations, Proxima Centauri b might have a large circulating ocean that can effectively transfer heat from one side of the exoplanet to the other. A similar process happens on Earth. For example, the east coast of the United States has a milder and warmer climate because the Gulf Stream carries warm water from the tropics there. In California, the ocean current brings cold waters from the north and prevents this side from getting too hot. So maybe Proxima Centauri b is really not a bad option for us. We probably won't be able to travel between stars if we play fair, and by playing fair, I mean following the laws of physics the way we currently see them. Playing unfair means using cheat codes. The big question is, do those cheat codes actually exist? Well, sorta. One of them is called a warp drive, a technology capable of interstellar travel. But how does it work? Let's find out. The first thing we need to understand is why a really fast spaceship isn't enough. Why can't we just build the ultimate engine, point the ship at another star, and go? The answer is distance. Space is too big. Right now, the fastest object ever created by humans is NASA's Parker Solar Probe. It was designed to fly extremely close to the Sun to study it. This probe uses gravity from Venus combined with continuous acceleration through the vacuum of space, which helped Parker reach a speed of about 430 miles per hour. But Parker is tiny, pilotless, and doesn't have to arrive anywhere. It just collects data and sends it back to Earth, and even at that speed, it's completely useless for interstellar travel. Compared to the speed of light, Parker is so slow that it's basically standing still. Light travels at about 669 million miles per hour. Now let's talk about the nearest star. Proxima Centauri is the closest star to our solar system, and it's about 4.2 light-years away in the constellation Centaurus. That means that even if we could somehow travel at the speed of light, it would still take more than 4 years to get there. Unfortunately, it's impossible. But why can't we go that fast? Why can't we reach Proxima Centauri in a year or even a month? The problem isn't engineering, it's energy. Any object with mass requires energy to accelerate. Think of a car. A 200 horsepower engine has a speed limit. If you want to go faster, you need more horsepower, more fuel, more energy. Physics lets us calculate exactly how much energy an object needs to reach high speed, factoring in mass, resistance, and distance. And here's the key point. As speed increases, energy requirements increase too. But when you approach the speed of light, the math stops behaving normally. The equations tell us that to actually reach light speed, you would need infinite energy, and this amount simply doesn't exist. That's why anything with mass can never reach or exceed the speed of light. If we play fair, interstellar travel is basically impossible. Yes, in theory, we could build a gigantic ship and send it drifting through space for tens of thousands of years, but that's dangerous, expensive, and wildly impractical. Which is why physicists started looking for cheat codes. One of those is the warp drive. It doesn't move a ship through space faster than light. Instead, it moves space itself. The idea was first proposed in 1994 by physicist Miguel Alcubierre. His solution showed that mathematically, we could distort spacetime in a very specific way by creating a bubble around a spacecraft. Spacetime in front of the ship contracts, spacetime behind it expands, and the ship sits calmly in the middle. From the ship's perspective, it's not moving faster than light at all, but from the outside, the bubble crosses enormous distances in very little time. If that sounds confusing, think about pulling a tablecloth off a table. If you do it fast enough, the dishes on the table don't move. So the dishes are the spaceship. The tablecloth is space-time. The table is a spot in another galaxy we want to get to. The ship doesn't slide across space. Space slides under the ship. Or imagine standing still on a moving escalator. Suddenly you jump and hold onto a crossbar on the ceiling. The escalator is moving under your feet when you jump off and land on a different step. The step that was far away from you before your jump. The escalator space was moving while you were holding the crossbar. So, the warp drive works on the same idea. Inside the bubble, passengers wouldn't feel extreme acceleration. Outside the bubble, space-time itself would be distorted. Sounds good, but there's a problem. The negative energy. Negative energy isn't just less energy. It's energy that behaves oppositely to normal energy. To understand it, we need to talk about something called the Casimir effect. You have two metal plates facing each other in a vacuum. They aren't charged, but they are conductive. There's no visible force acting on them, and yet a negative force pulls the plates toward one another. What does that mean? The plates are in a vacuum. Nothing is pushing them together. There's no classical energy involved. The plates are completely inert, but between them, quantum fluctuations create pressure that slowly forces the plates closer together. Let's not dive too deep into quantum physics and melt our brains. The important thing to understand is this: the pressure acting on the plates is not created by ordinary energy, but by negative energy. And more than that, it acts on space itself. Once again, normal energy makes objects move through a vacuum. Negative energy makes the vacuum itself compress. The Casimir effect proves that negative energy exists, but only in microscopic amounts. We can measure it, but we can't store it, scale it up, or control it in any useful way. For a warp drive, we would need unimaginable quantities of negative energy, enough to compress and stretch space-time around an entire spaceship. And right now, we have no idea how to generate that much negative energy, or whether it's even possible. That's why the warp drive working on negative energy is impossible. But why have scientists recently said interstellar travel might happen? because scientists proposed a warp drive model that doesn't require negative energy at all. Using extremely complex mathematics, researchers showed that it might be possible to create a warp-like effect using only ordinary, positive energy and the usual laws of physics. Here's a simple analogy. Imagine you need to lift a house using a crane that weighs 1 billion tons. That's the classic warp drive with negative energy. Theoretically possible, but completely unrealistic. The new idea is more like shifting the house using an incredibly complex system of pulleys, supports, and leverage, instead of the billion-ton crane. This new warp drive concept exists only on paper. The technology required to control space-time with that level of precision is far beyond anything we can currently build. It may take decades, it may take centuries, or it may turn out to be impractical after all. At the moment, the most realistic way to travel between stars is to board a massive spacecraft powered by a thermonuclear engine, capable of accelerating to incredible speeds. Yes, the journey would take a very long time, hundreds of years, but by then, human lifespans may be much longer. On top of that, we could use cryogenic capsules. You get on the ship, fall asleep in a pod, and wake up thousands of years later in another star system. It's possible that during that time, scientists back on Earth have invented a warp drive or some entirely new technology. Even so, this approach is still extremely dangerous. What happens during the journey? What if the ship breaks down or the destination planet turns out to be uninhabitable? Of course, all of these risks would have to be carefully calculated in advance. Another way of such travel you've probably seen in the Interstellar movie. Remember how the characters flew to another galaxy? They entered a wormhole, a tunnel connecting 2 points on opposite sides of the universe. Waiting around and hoping that a wormhole will just appear somewhere isn't exactly a great plan. Trying to invent such a tunnel ourselves? Maybe. In a few hundred years, technologies like that might exist. In any case, all this will not come home soon. But for now, let's enjoy traveling not between the stars, but between cities, countries, and continents. Fortunately, we have reliable technologies for such trips.
Just watching certain scenes from the movie Gravity was scary, let alone imagining what would happen if you really ended up in the cold, endless void called space without knowing if you'd be able to go back. But let's say you're really up there. You're so excited about your first spacewalk. It sounds risky, but it's something astronauts on the International Space Station do quite often. It's easy to understand why accidents at work are way scarier up there than some regular 9-to-5 job on Earth. But that's why you have more training and special equipment to keep you safe. First, astronauts are always attached to the spacecraft with tethers, so they don't float away like a helium balloon. It may seem like a spacewalk is such a big deal that the ISS needs to stop when the astronauts are out there doing their thing, but it's not like that. If the ISS were ever to stop, it would fall straight down to our planet. So, once an astronaut is in a stable orbit, they stay in that orbit, unless some new force acts out. The first spacewalk wasn't as simple as those done later. It was performed in 1965, and it lasted 12 minutes. 2 men set out on a mission. One of them was supposed to float in space for a while taking pictures. But things went wrong. His spacesuit expanded too much, making it hard to move. He started to feel overheated, so he had to let some oxygen out of his suit, which was very risky. He could run out of air or get sick like a deep-sea diver. Getting back into the spacecraft was tough as well, but he somehow managed to do it. Then, more problems came. The spacecraft started spinning, oxygen levels rose dangerously, and there was a risk of an explosion. After a lot of struggle, they made it back to Earth, but landed in a random forest surrounded by wolves and bears during a snowstorm. It took a rescue party to find them. Not a very encouraging story to listen to while you're waiting to go out. But cheer up, things have improved since then. Hundreds of astronauts have taken spacewalks without any serious problems. So here you are, whizzing right along with the giant ISS. Your first spacewalk goes almost flawlessly, so you can enjoy the view a bit. It's hard to control the way you move, but tethers still do their job, so you can focus on your task. Until you realize they failed. How did they untie? You notice you're floating off in some random direction. There's nothing you can hold on to. Your body is weightless, and it has started to spin around. It's so frustrating when you can't take control of your movements. An astronaut named Scott Kelly described this unpleasant feeling in his book Endurance. He was turning around and upside down in the darkness and could see nothing but what was right there in front of his face. It was like a scuba diver floating in murky waters, totally disoriented, with no way of telling which direction was wrong and which one could be right. In space, you can't kick or flail to change your course. It might be fun floating inside a spacecraft with zero gravity, playing and fooling around, but seeing just the endless void filled with stars in the distance and knowing what could happen makes it frightening. And now you're getting closer to Earth's atmosphere. It might seem like the safest option because it makes you feel like you're going home, but in reality, you better hope you'll change direction. If your angle and speed are wrong, you might re-enter the planet's atmosphere and burn up. Not a good deal. NASA trains astronauts for such situations, so you know what's your next step: activating an emergency jetpack called SAFER. This tool is designed to help you stabilize and move in space. You don't even need the tethers. You can control the movements of your jetpack with a small joystick. Finally, all those hours of playing video games will pay off. These jetpacks became an inevitable part of the spacewalk package almost 30 years ago. So far, no astronaut has had to use one during a spacewalk. Whew! You're back on track, and you're moving away from Earth's atmosphere. You're getting closer to the ISS, flying manually. Oops! These jetpacks have one big flaw. They have a limited amount of fuel, and your SAFER has just run out of it. Okay, take a deep breath. One of the most important things every astronaut has to learn is to be prepared for literally anything. That's why they go through pretty intense training sessions, so they can remain calm even in very stressful situations. A long time ago, NASA would choose astronauts from test pilots who went through harsh training in the jungles of the Philippines without any help, so no instructions or supplies. Later, they implemented a special training regime with outdoor exercises in different climate environments and even underwater to simulate conditions in space. Today, astronauts are trained to work in teams to stay focused and calm while handling difficult tasks. For instance, when they needed to fix the Hubble telescope, astronauts had to work for more than 8 hours in the harsh conditions of space to remove a broken part. It was a frustrating task. Plus, the gloves they had to wear made things harder, but they still did it. They also train in a giant water pool in Houston, which is a pretty good replica for the ISS. That's where they practice spacewalks and try to repair things while being underwater all the time. The water makes them feel weightless, while their suits are heavy enough to mimic the effects they could experience during spacewalks. You also need to have sessions with aerospace psychologists. They help astronauts handle stress and stay mentally strong. They check astronauts before, during, and after missions, helping pick the best candidates for spacewalks. Not everyone can go through these harsh conditions. Out of 16, only 10 get chosen. Even though so many safety measures are taken, space is still an unpredictable place where we don't have as much power as we'd like to. Back in 1973, during a spacewalk on the Skylab space station, 2 astronauts were in a very risky situation. They were out in space fixing things, but they didn't have the same handy jetpacks like astronauts do today. They could only rely on safety tethers. Suddenly, the solar arrays they were working on moved unexpectedly and pushed them out of their position, almost sending them drifting off into space. Thankfully, the safety ropes did their job. Strong, resistant to heat, and attached to astronauts' waists, these tethers can hold a weight of about 881 pounds. This accident happened before SAFER came into use. When up in space, a lot of things can go wrong, and sometimes even astronauts' training and equipment can't help solve the problem. That's where the Mission Control Center on Earth jumps in. Thousands of people work on Earth to support the astronauts on the ISS. But if the communication system doesn't work, or no one's close enough to help, that's where the rescue operation stops. You just continue to move in a random direction, waiting for the 7.5 hours of air you have to run out. Feeling hungry? Unfortunately, you can get nothing but some water you have in your helmet. Maybe you'd stop spinning at some point. The view would be fascinating. You could watch the Earth rise and set about 5 times, depending on where you are. And while you'd be getting farther away, and Earth would be turning into a small dot lost among asteroids, stars, and space debris, a random picture would come to your mind. A stunning sunset at the beach, the sound of waves, and your favorite pizza. Now, it's so far, it almost seems like part of another dimension.
Let's say a spacecraft runs out of power far in deep space. It wouldn't fall in the traditional sense because there's no gravity. Newton once said that an object remains in motion unless acted upon by an external force. In our case, this external force is gravity. In other words, if there's nothing with gravity around, it would continue to move due to inertia. It would keep going the way it did, without us being able to change its trajectory or adjust it in any way. It would keep traveling through deep space, almost forever. Well, at least until radiation and cosmic rays destroy it. And unless some celestial body like an asteroid doesn't destroy it either. And of course, unless it encounters something with a gravitational pull, like a planet or a star. The likelihood of all this depends on the location and trajectory of the spacecraft. Voyager 1 was launched by NASA in 1977. It's been on its journey for almost 50 years now. Right now, it's the farthest human-made object from Earth, more than 50 billion miles away. It's already very far from all our planets, and it's the first spacecraft to enter interstellar space, the vast, empty space that exists between stars in a galaxy. It's the space outside our solar system, where there are no planets, moons, or other objects associated with our Sun. However, it's still in our solar system. To leave it, Voyager 1 needs to bypass the Oort cloud, a big, icy collection of objects where all the comets in our solar system probably come from. It will take Voyager about 300 years to reach the inner edge of the cloud, and then about 30,000 years to bypass it. Voyager 1 has a special plate on board, like a message in a bottle. This plate is called the Golden Record. It's not really golden, it's actually a shiny gold color. On this plate, there are things that tell a story about Earth. It was created in case Voyager ever encounters any extraterrestrial beings. The record has greetings in different languages, music from Earth, and even the sounds of nature, like birds chirping and the wind blowing. As the distance between us increases, the signal strength from Voyager 1 weakens over time. Eventually, it may become too weak to be detected by our communication equipment. The power output of Voyager 1's engine also declines over time. It's slowly running out of fuel. When all its systems shut down, we will lose contact with the spacecraft. Voyager 1 will work until 2025. After that, it will continue its journey on inertia. Luckily, it was designed to last, and the chance that it will encounter anything on its way is very small. Considering this, it might even keep going for billions of years. One day, it might even reach other star systems, and maybe even outlast our Sun. The same goes for Voyager 2. It will keep traveling until it reaches interstellar space, joining its twin brother. Voyager 2 will continue to send us scientific and systematic data for a while, even in interstellar space. However, it will also cease to function eventually, becoming a silent artifact drifting through the Milky Way. When there's something with gravity near the spacecraft, the inevitable happens. It falls onto that object. This is why out of the vast South Pacific Ocean beyond New Zealand lies a unique and intriguing place known as the Spacecraft Cemetery. Officially, it's called the South Pacific Ocean Uninhabited Area, It's located near Point Nemo, the most remote spot from any island. It serves as the final resting place for spacecraft that have completed their missions and reached their lifetime limit due to wear and tear. Sometimes, these larger spacecraft are too hefty to burn up during re-entry into Earth's atmosphere. In that case, they're directed to crash or splash down in this remote ocean location. This helps protect us from any potential harm during re-entry and impact. There are, however, some big problems with this place. Scientists are worried about the impact this spacecraft cemetery has on the ocean. When spaceships come back to Earth, they often spill chemicals. One of these chemicals is hydrazine, a dangerous rocket substance. Unfortunately, it might not completely burn up during re-entry, so it leaks out into the ocean, posing a threat not only to marine life, but to us as well. We made up some rules, both within countries and internationally, to stop this. However, it's not easy to figure out how risky it is for certain spacecraft to enter the cemetery. We can't say for sure how much of a substance is left after it enters the air. As for spacecraft that don't fall, they're often left in space as debris. This is what we call any man-made object orbiting Earth that's no longer useful. It's also very dangerous. There are over 27,000 pieces of space debris orbiting Earth at high speeds. All this puts human and robot missions at risk and harms spacecraft. As we mentioned, usually we get rid of space debris by trying to bring the crafts back to Earth. This makes them burn up when they re-enter due to high speeds and air pressure. This usually works with smaller objects. There are also riskier methods, like letting spacecraft break down themselves, or crash into other things, or blow up. These methods aren't great because they just make up even more debris, even if it's smaller. So now, scientists are trying to find new ways to get rid of retired spacecraft. For example, nets and magnetic arms. There's also a thing called reusable spacecraft. It's a space vehicle that's built to be used more than once. For example, space planes such as the Space Shuttle and the Dream Chaser, or capsules like the SpaceX Dragon. They're designed to launch, orbit, come back to Earth, and do it all over again. But it's important to make sure these spacecraft and their passengers or cargo stay safe during the return, which is quite hard to do. Reusable spacecraft have special systems to guide them back to Earth safely. The Space Shuttle, for example, had OMS pods, sort of special backpacks that help the spacecraft move and control its position in space. The SpaceX Dragon had its own engines to slow down and enter the atmosphere in a controlled way. They also have a heat shield to protect it during re-entry. The heat shield can be made of different materials, but they need to be tough and able to withstand multiple trips. Coming up with a heat shield that's both strong and lightweight is a bit of a challenge. Finally, if a spacecraft lands on a runway, it needs wings and landing gear. They also add weight. Some designs like lifting bodies or the delta wing of the Space Shuttle try to reduce the mass of these parts. After landing, the spacecraft might need some fixing up before it can go on its next adventure. This process can take a while, up to a year, and it might not always be possible to use the spacecraft again if it's been fixed up. There's also a limit to how many times a spacecraft can be fixed and used again before it has to retire. Different spacecraft have different abilities to be reused. Finally, sometimes we can rescue a spacecraft or even remake and repurpose it. Voyager 2 is one of the examples. It had a little trouble with its radio in 1978. Engineers fixed it by using a backup system. Since then, it's been exploring our solar system for over 40 years. The Hubble Space Telescope is the most famous telescope we have, the grandfather of them all. However, it had a blurry start in 1990. The work wasn't done at all as expected. The pictures were of low resolution. Luckily, astronauts fixed it right in space in 1993. To do that, they used some corrective mirrors. Now it gives us fantastic views of the universe. As you can see, even in bad scenarios, there are many possible options to solve spacecraft-related problems.
So tonight, go out and look at the moon through a telescope, and you'll see many craters. No one still knows how they appeared there. Some of them have formed recently. Scientists have discovered a double crater on the moon that appeared for a strange reason. In March, a rocket crashed into the moon, and no one knows who owned it and why it left such a trail. If a regular rocket had fallen there, it would have left one hole. A standard space rocket has a heavy engine on one side and a lighter fuel tank on the other. But this time, there had to be two heavy sides on one rocket to leave a double crater. That's strange. No one knows what it is, and no one has claimed to be the owner. It was probably part of a large 3-ton rocket. This piece had been flying in space for several years. At first, astronomers thought it belonged to SpaceX, but the company denied this claim. Also, they thought that China had launched the rocket, but this was also wrong. In the near future, NASA experts hope to find out the truth. The problem with tracking such rockets and space debris is that this is quite expensive. Companies don't want to spend too much money on it. But soon, this will change. People will have to spend billions of dollars to monitor garbage or destroy it, since it's getting too crowded in space. Space companies will have to solve this problem, as it poses a serious danger to satellites and spacecraft. Just take a look. There are millions of pieces of satellites and rockets flying in space. Some of them are the size of a basketball, others are as tiny as a raindrop. The total weight of all this debris is about 9,000 tons. This is almost 2,000 tons heavier than the Eiffel Tower. Okay, all this garbage is floating there, so what? The problem is that it's not just floating, it's moving at a speed of 17,500 miles per hour. A tennis ball will fall apart into several pieces at such a speed on the surface of our planet because of air resistance. But there's no air in space. Nothing prevents a tiny piece of metal from reaching a speed 20 times faster than the speed of sound. A piece of paint at this speed can easily damage the casing of a spaceship. Once, several shuttle portholes were replaced because of the damage caused by flying chunks of paint. Now imagine what a piece of metal the size of a basketball can do to a spaceship. It could bring down the International Space Station. Many satellites were destroyed by space debris that crashed into them, and when those satellites exploded, they burst into thousands of small parts, which also turned into dangerous flying objects. For example, in 1996, a fragment of a rocket damaged 10 years earlier crashed into a French satellite. In 2009, a failed spacecraft destroyed another commercial ship. As a result of the collision, about 2,300 tracked fragments appeared, as well as lots of tiny untracked ones. Today, satellite operators receive warnings about potential collisions with space debris, but these messages are often either inaccurate or reach the operators too late. Imagine that a screw is flying at great speed toward your satellite. You'll hardly have time to dodge it. Perhaps it won't hit your satellite at all. This uncertainty makes these warning sensors useless. The problem becomes much more serious when it concerns the ISS crew members. A durable spacesuit can't guarantee protection from flying debris, and the station itself is too large to save itself from big objects by dodging. To keep astronauts safe, scientists have a catalog of things that are the size of softballs or bigger. They monitor thousands of fragments and analyze their trajectories, material, and dimensions. Next, they use the pizza box method to dodge garbage. This is the unofficial name for an imaginary square that is used to calculate the risks of a collision with space debris. So imagine a giant pizza box. It is 2.5 miles deep, 30 miles wide, and 30 miles long. Now put the entire International Space Station in this box. Yeah, okay, you can have it with pepperoni. Anyway, if some space object is heading toward the edge of the box, the crew will begin to develop a plan of action. The box's radius is quite large compared to the station, since it's difficult to calculate the debris' trajectory. If there's a chance that something might approach the box, then it can also damage the station. When operators receive a signal about approaching debris, they analyze it. Depending on the data received, the crew begins to act in a certain way. If it's something small and heading for some part of the ISS, the astronauts should evacuate from this part, and after that, they'll do repairs there. If something big is approaching, the entire station can perform an evasive maneuver with the help of the engines or a docked spacecraft. One such trick required about 5 hours of hard work. The station is a big, clumsy ship, so it's important to know about the threat in advance. From 1999 to 2020, the ISS made 29 maneuvers to avoid collisions. 3 of them occurred in 2020, and there will be more since the amount of garbage increases. If some object is too big and fast and can damage critical components, and it's impossible to dodge, the entire crew will have to evacuate. In the future, NASA and other space agencies will have to think about how to destroy this debris or remove it from orbit. One option is catching everything with extensive space nets. One agency suggested developing a solar sail that clings to debris and propels it to a low orbit. Another wanted to use an electrodynamic cable to slow down the speed of space debris with the current. This maneuver will cause space garbage to move toward the surface of Earth and burn up in the atmosphere. But what if one of these pieces still reaches the ground? Even now, many satellite parts fall on Earth. Fortunately, this is not so dangerous. The probability of cosmic garbage falling on your house is minimal. In addition, 70% of our planet is covered with water. Of the remaining 30%, only 3 to 10% are occupied by people. Almost all space debris falls into the ocean or unpopulated parts of dry land. But let's say some part of a satellite damages your property. In that case, the company that owns this space object will cover the losses. Such cases are rare and occur because of accidents in orbit. But sometimes, companies intentionally abandon their satellites. If a spacecraft is out of order, they turn it off and use the remaining fuel to slow it out of orbit and drop it in a safe place. Almost all such objects fall in the region of the spacecraft cemetery. It's located at the most remote point on Earth, Point Nemo. It's in the southern Pacific Ocean, east of New Zealand. The nearest island is more than 1,000 miles away. The distance to the International Space Station is much smaller. It's challenging to get to this place since no ships travel there. That's why most satellites end up in that area. It looks like an endless sea. The ocean there absorbs explosive waves of any power without consequences. Even if some fallen ship or rocket causes a giant wave, it dissipates long before it reaches dry land. Fish and other marine creatures are also not at risk. Point Nemo is one of the least inhabited areas on Earth. Underwater currents carry nutrients through the ocean, and tiny living creatures such as phytoplankton and other organisms feed on them. But these currents don't reach Point Nemo. Another way to deliver nutrients in the ocean is wind, but there's almost no wind at Point Nemo. This place doesn't have enough food to let large life forms develop. Just imagine how lonely and silent it is there. Sometimes a broken rocket breaks this silence, crashing into the water at great speed and descending to the seabed, where thousands of other satellites are waiting to welcome it.